Okay, so in the last class we discussed about electric current. We discussed a modular problem on the current, electric current, some basic problem, and then we discussed as to how the electric current, that means the electric charges when flow in a conductor, how is it being obstructed by the materials of the conductor. So, and then we discussed about we just termed about the property of resistance, and we discussed that resistance of an electric conductor is what, though it goes a little ahead of the course of standard 10, but we'll just have an idea as to what actually happens inside the conductor. So as we discussed, a conductor is a combination of so many free electrons inside the conductors, and free electrons are those valence electrons which has been brought, which has come out of the of the parent atom of the conductors. And as we know that inside a neutral atom, the magnitude of positive charges, which are specially or mostly because of the protons inside the nucleus, and the negative charges, which are the revolving electrons inside the nucleus, revolving charges of the electrons around the nucleus are equal. And when suppose the valence electrons are, say, ejected out from the parent atom, so there is a vacancy there is a deficiency of the negative charges with the parent atom, and the parent atom becomes positive. So and the parent atom has a large number of protons inside it, so many neutrons, and then those revolving electrons which are not the part of those valence electrons which have been emitted out from the atoms. So that means the entire body is a little massive, is a little heavier. So we call that body, that leftover of the family of the atom, from where those valence electrons have left and become the part of the conduction electrons. We call those family of atoms as the positive lattices. They're very heavy. Okay. So suppose we talk about we are talking about the conductor. Suppose this is a conductor, and we are referring the positive lattices as this plus, encircled plus, electrons with E. So there are so many positive lattices. The electrons, so positive lattices and electrons are there inside the conductors. So many positive lattices, so many electrons, positive lattices and electrons are there. Okay. So some this kind of picture is there. Okay. Now suppose if this is the conductor, this is the wire. Conductor means the traditional wire which we talk about. So if we take this wire, if we connect the two ends of the wire with a battery, like a battery we connect in a remote control, a battery which we add in a torch. So this bigger symbol is actually for the positive or higher potential of the battery, and this lower one, this lower standing line, looks for the negative potential of the battery, or and this is the higher potential, lower potential. Okay. So when it is connected, what happens? This positive repels or try to repel the positive lattices and tries to attract all the free electrons. So this way, all the electrons are attracted towards the positive lattices and towards the positive plate of the battery, and all the negatively charged electrons, all the electrons, free electrons, are attracted towards the positive plate, And because the positive plate, all the positive lattices are repelled back towards the other end of the conductor. And if we talk about the significance of the negative plate, what happens? This negative attracts all the positive lattices, or may try to attract all the positive lattices, and repels all the negatively charged free electrons. Okay, so this is what the tendency that we have already discussed through this Coulombic laws, as we discussed, as we had some idea about the Coulomb's law as to what happens when two electric charges are there, say Q1 and Q2, if they are say separated by a distance r. So the force between the two charges is 1/4, say some constant, we call it constant, a constant k, and then this is the product of the two charges divided by r square. This type of say, sometimes it is repulsion, sometimes it's attraction, depending upon the properties of the charges. When both the charges are of the same nature, that means both are positive or both are negative, there will be a repulsion. If the charges are of opposite nature, say one is a positive charge, the other is a negative charge, there will be an attraction. Okay, so that is this. So now referring to here, coming to this point. So what happens is, since electrons are lighter body, you can say, you can correlate the entire picture like in your family. It's very difficult for your father to just get up and open the door, as compared to you, who has a lesser mass, who is quite energetic. So these free electrons are of very smaller masses, they are light bodies, and it's always easier for these electrons to respond to any of the interactions to which they are subject to. But this does not mean that your father will not have a response from his side when there is a knock on the door. So there will be a response, but the response by these negative charged electrons would be quick and faster. So all these negatively charged electrons will try to rush up, and while rushing up, they will have a collision with the electrons and positive lattices, electrons and electrons, positive lattices, positive lattices. So, and this randomization, this random collision is there even when there is no such connection, even when the circuit is open, the circuit is not closed. So even then this collision is there. This collides, even when it doesn't, they are not closer. Then also such you can say state of affairs is there inside a conductor, that although electric charges keep on moving inside a conductor, even when there is no such connection of electrical energy or a battery, but this movement of charge does not constitute electric current as per our definition of electric current. What did we define electric current? Keep in mind, we defined electric current as the rate of change of net electric charge, or say the rate of flow of a net amount of electric charge crossing a particular cross section of the conductor. When no such battery is connected, say one negative charge goes here, the other negative charge goes this side, say one positive charge goes here, the other goes this side, that means the net flow of electric charge to a particular cross section is zero. One went from from left to right, the other went from right to left. So this way there is a cancellation of the net crossing of charge through a particular cross section in our consideration. So that means there is no net electric current. But as soon as this connection is established, all the negative charges have an impression to go towards the positive end of the battery. All the positive charges have a relative impression to go against the movement of the negatively charged free electrons, and thereby then a net flow of charge is established through a particular cross section of the conductor. Now we have already discussed it. What I am about to emphasize here at this point is that about this randomization and collision, this vulnerable collision. This collision is always there. When the electron goes from here to here, this may have a statistical collision. This may have a possible collision. Now, because of this collision, because of this vulnerable collision inside a conductor, inside the body of the conductor, one electron which could have in the absence of this picture of the conductor, that means the existence of the positive lattice and negative charges, if these would not have been, the electron could have gone straight away from here to here, and all the positive lattices could have gone from here to here. But because of the existence of so many free electrons and positive lattices, the picture is what? The electron go here, then maybe here, then maybe here, then maybe here, then maybe here. So it's a zigzag path. That means the flow is not smooth. You can say the flow is not the flow of the charge is not straight. And the same happens with the positive lattices as well. Although their speed is very less because they are very heavy. So this character, because of this character, we know that whenever there is a collision, suppose you want to go in a fish market, and suppose from one end of the market you have to travel to the other end of the market. There is a large crowd in the market, so you will always have your path will not be a straight path. You will have sometime you will go left, then you will go right, then you will go. Although you have an impression in your mind that you have to go to the other end of the market, but you may not have that straight motion. So, and while doing this all, there is you can say there is a kind of loss of energy from your side. There is a kind of loss of energy from your side. The energy which you could have devoted while going from here to that end quite consistently cannot be delivered that way. Your energy will go in going right, in going to left, and this way there is a large consumption of energy. So, and here there is a collision, and because the collision, whenever there is a collision, there is a production of heat. The system gets heated. There is a temperature which there is an increase in temperature in the system. So there is an obstruction offered in the path of flow of the electric charges through a particular cross section in the conductor, and this obstruction itself is called resistance. As we defined in the last class, that what is the resistance? Resistance is the obstructions offered by the conductor in the path of the flow of electric current. And how come these obstructions come? These obstructions come from this picture of electric conductor. There are so many hindrances in the path of electric current while going from one side of the cross-sectional area to the other side, and this property, this hindrance is called what? This hindrance along with how long the tunnel is. This is a kind of channel. This is a kind of tunnel. It's a tunnel for the motion of the electric charges. So this tunnel is not free. This tunnel has so many you may say there's so many polybags, so many disturbances, so many big stones. So this type of hindrances are there. The longer the canal is, the longer will be the obstruction. The lesser the canal is, the lesser will be the obstruction. Similarly, if the canal is wider, suppose you are taking an electric conductor which is quite wide. The radius is large. The cylindrical radius is large. So what will happen? The hindrance will be small. You would have seen in a larger canal, water flows relatively freely as compared to the smaller pipes. So similarly, if the conductor is larger in length, again this obstruction will be for a longer time. So the electric current will have to suffer so many hindrances while crossing one end of the conductor to the other end. That means, and then what? And then the electric current has its own character. How many positive lattices are there in unit volume? How many free electrons are there in the sample of the conductor? This also is going to matter while calculating these hindrances. So in a nutshell, all these hindrances are conceptually called resistance. All these hindrances are conceptually called resistance. And this resistance is also a physical quantity which can be measured as this rho times L divided by A, where rho is what? Where rho is one of the internal characteristic of the conductor. This we are calling rho, and this rho is what? This is called resistivity. This has been named as resistivity of the conductor. What is this resistivity? This is an internal characteristic of the conductor. How many positive lattices are there? How heavier they are? How many free electrons are there inside it? What is the general character of that conductor? How fast those electrons could move? How much time they take while moving from one point to the other point? All these things are calculated into by this physical quantity called resistivity. This is an internal character. Even if we take a small length of the conductor or of a small radius of the conductor, this rho is not going to change. This will remain as it is. But this length, this L is what? The length, and A is what? The cross-sectional area of the conductor. This L and A depends upon the conductor, upon a particular conductor, how long that conductor is, how large is its radius, how large is its cross-sectional area, because A will be pi r square. This is a circular area. So the longer the radius is, the longer will be the cross-sectional area. So the resistance can be measured by the formula rho L by A, where rho is called what? Resistivity, which is an internal property of the conductor, I must say. An internal property means it depends upon what is the number of electrons per unit volume in the conductor, what is the number of positive lattices in the conductor, what is their internal characteristic. Over this depends. So there is a tabular values of all in your class, you will get it for resistivity. But resistance may change as we change length and cross-sectional area of the conductor. Is this clear to you? That what is resistance? You can have an idea, you can have a difference between resistivity and resistance. Resistance is a physical quantity which depends upon the length, cross-sectional area and resistivity of the conductor. Resistivity is an internal characteristic of the conductor which depends upon the total number of positive lattices and free electrons per unit volume in the conductor and their internal properties, other internal properties. The resistance can be measured in terms of ohm. Resistivity can be measured in terms of ohm meter. You can find it from here also. This is ohm, and then you can calculate rho is equal to what? Ra upon L. So R can be measured in terms of ohm. So ohm meter square upon meter. So meter and meter can be cancelled, so it becomes what? Ohm meter. So this can be measured in the SI unit of ohm meter. And then you can say if we increase length, or if you increase length, resistance will increase, resistivity will remain ineffective. If you increase cross-sectional area, the resistance will decrease, but resistivity will remain ineffective. So this way, we can have an idea as to how the resistance and resistivity can be differentiated.